So, you want to learn embedded systems in 2026. You've probably noticed it's a bit of a jungle out there. You've got tons of tutorials, a million different development boards, and a lot of advice that just conflicts with each other. It's really tough to find a clear path. Well, in this explainer, we're going to cut right through all that noise. We're going to build a practical, modern roadmap for mastering what is, without a doubt, one of the most dominant platforms in the professional world, the STM32. Let's get right into it.
You know, this quote from a user on Reddit, man, it just hits the nail on the head. It perfectly captures a frustration I see every single day. You're ready to learn, you might even have a cool project in mind, but you find yourself wading through this minefield of tutorials that are 5, 6, even 10 years old. And that's not just annoying, it's a huge barrier that literally stops talented people from ever getting started. That is the exact problem we are going to solve right here, right now.
Okay, here's our game plan for today. First, we're going to get a really clear picture of what embedded systems even means here in 2026. Then, we'll dive into why STM32 is such a solid foundation for a real career. Next, we'll uncover the absolute best official resources to get started, we'll weigh the pros and cons of free versus paid courses, and then I'm going to share the most common, painful beginner traps I've seen people fall into. And finally, we'll put it all together into a personal roadmap that you can start using today.
So let's just start with the reality of the situation. Learning embedded systems today is a completely different beast than it was even just a few years ago. You see, the problem isn't a lack of information, it's an absolute sea of it. Honestly, your first real skill, before you even write a single line of code, is learning how to navigate that sea without getting lost.
I mean, the complexity of this field has just exploded. We've gone from simple little microcontrollers that just blink an LED to these incredibly powerful devices running AI models right on the edge, handling secure communications, managing complex wireless protocols, the whole shebang. Because of this, just winging it with random tutorials you find online, it just doesn't cut it anymore. A structured, deliberate learning plan is absolutely critical.
So in this really complex world, why are we focusing so hard on STM32? Simple. Because it's a platform that gives you a direct, scalable path from your very first hobby project all the way to the kind of professional work that actually gets you hired. This isn't a toy. It's what's being used in millions of commercial products as we speak.
And this slide really breaks down the why. At its heart, you've got the industry-standard ARM Cortex-M processor. That alone is a huge advantage. But the real magic of STM32 is the entire package. You get a massive library of built-in peripherals, things like ADCs, timers, communication interfaces, plus a mature software ecosystem, fantastic low-power capabilities, and a product line that scales all the way from a tiny sensor node to a massive industrial controller. You learn it once, and you can apply that knowledge practically everywhere.
Now, to actually work with these powerful chips, you need to get comfortable with the core software tools. The good news is ST Microelectronics provides them completely for free, and they form the backbone of your entire development process. Let's break down the two most important pieces you'll be using pretty much every day.
First up, you have STM32CubeMX. The best way to think about this tool is like your project's architect. It's a graphical tool where you literally click to set up your microcontroller. You assign pins, configure clock speeds, enable peripherals, all visually. Once you've designed that configuration, it spits out all the startup code for you. Then, you take that project and you open it up in STM32Cube IDE. The IDE is your workshop. It's where you write your actual application logic, where you compile your code, and where you debug it right on the hardware.
Now, inside the code that CubeMX generates, ST gives you a really important choice, your abstraction level. For pretty much all beginners, you're going to use the HAL, or the hardware abstraction layer. This gives you really simple, easy-to-read functions like HAL GPIO write pin. It makes prototyping super fast. But as you get more advanced, you might need more performance. That's where the LL, or low-layer APIs, come in. They're much closer to the hardware, giving you finer control for smaller, faster code. The key takeaway here is simple. Start your journey with the HAL. It's the modern way, it's the recommended way. But just keep in the back of your mind that the LL is always there for when you need to squeeze every last drop of performance out of that chip.
Okay, so we get the why and we get the what of the tools. So where's the absolute best place to actually start learning all this? My advice is always the same. Go directly to the source. Start with the materials provided by ST Microelectronics themselves. ST has this amazing library of free massive open online courses, or MOOCs. Now, the key thing here is that these are taught by the actual ST engineers who design these chips. You can't get any closer to the source than that. They're self-paced, they cover a huge range of topics from basic to advanced, and all you need is one of their super affordable Nucleo boards to follow along.
And because they come from ST, you know they're authoritative and up-to-date. This is without a doubt the most reliable place to start, period.
And to give you a concrete launchpad, these are the two MOOCs I tell every beginner they have to start with. First, STM32 Cube IDE and CubeMX Basics. This will make you comfortable and proficient with your main toolchain. Do not skip this. Once you've got that down, take the free RTOS on STM32 course. Learning a real-time operating system in RTOS is what separates the hobbyist from the professionals. It's how you manage multiple tasks reliably, and it is a non-negotiable skill for any modern embedded system.
So once you've built that solid foundation from the official MOOCs, the learning world kind of splits into two big paths. You've got the free, quick start courses, and you've got the more comprehensive, paid programs. Now, it's not about one being better than the other. They're just designed for totally different goals. So let's break down when you should pick each one. This table really lays it out. On one side, you have free courses like STM32 Essentials from Great Learning. In just a couple of hours, you'll get a really solid overview of the fundamentals and the tools. This is perfect if you're just exploring, trying to see if this whole embedded thing is for you. Then on the other side, you've got paid, deep dive programs, like the STM32 Path from Embedded Expert IO. This is a serious 90-plus hour commitment designed to build job-ready skills. It takes you from the absolute basics all the way down to bare metal programming, which means coding directly on the hardware with no safety nets. The choice is pretty simple. Use the free path to explore, and then commit to the paid path when you're ready to really specialize and invest in your career.
Okay, let's talk about some hard-won wisdom here. Every single beginner makes mistakes. That's just part of learning. But knowing the most common pitfalls ahead of time can save you weeks, even months of frustration, and honestly, it might prevent you from giving up entirely. So listen up, because these are the biggest traps I see new engineers fall into time and time again.
First, and most importantly, do not skip the fundamentals. I know you want to get to the exciting stuff, but trust me, if you can't confidently configure a clock tree or toggle a GPI open from scratch, you will hit a wall. Master the basics. Second, avoid tool hopping. Don't waste your time jumping between 5 different IDEs. Just pick the official STM32 Cube IDE and master it. Third, and this one is critical, resist the urge to just copy and paste code you find online if you don't understand it. Deconstruct every single example line by line. And finally, please, start small. Your goal isn't to build an autonomous drone this weekend. Your goal is to build a simple data logger that actually works reliably. Getting that done is a huge win.
All right, we've covered the landscape, the tools, the different learning paths, and the traps you need to avoid. Now for the most important part. Let's pull all of this together into a practical, actionable roadmap that you can start following the second this explainer ends. Here it is, a simple 4-step plan. Step 1, gear up. Go get yourself an affordable STM32 Nucleo board. They have an integrated programmer and debugger right on board, and they are incredibly well supported. Step 2, start at the source. Go and complete those official ST MOOCs on the Cube IDE and the HAL basics. Step 3, build a foundational project. A sensor data logger is a perfect choice because it forces you to correctly use GPIOs, a communication peripheral like UART, and timers. This is your rite of passage. Then, step 4, specialize. Once you've built that solid foundation, you've earned the right to dive into a topic that really excites you, whether that's RTOS, wireless stuff, or embedded AI.
And remember, this roadmap is your main path, but you're not walking it alone. Make sure you supplement your learning with community resources. Go search on GitHub for embedded roadmaps. You'll find these amazing curated lists of tutorials and projects. And seriously, invest in a classic reference book like Mastering STM32. It will be an invaluable companion on your desk for years to come.
So if there is one core idea I want you to take away from all of this, it's this. Success in modern embedded systems is all about balance. It's about using the high-level tools like the HAL to be productive and to get things working fast. But you should never stop being curious about what's actually happening underneath. That deep, fundamental hardware knowledge is ultimately what's going to set you apart as a truly skilled engineer.
So there you have it. Your roadmap is ready, the tools are free, and the best learning resources are out there just waiting for you. The only question left is the most important one of all. What are you going to build first?
If you like this one, the YouTube algorithm says you're going to love my other videos, so go check them out.